Welcome back, children. Today we will deal with air pressure. Now, all of you know that the earth is covered by a blanket of air which is called as atmosphere. Now, this air has weight which exerts on any object or on the surface of the earth downward. So the pressure which is exerted by the weight of air on unit area of the surface of the earth is called as atmospheric pressure. The normal atmospheric pressure is 1.01 into 10 to the power 5 Pascal. Remember, so this is the normal atmospheric pressure. So this pressure is exerted throughout the surface or on any object which is on the surface of the earth. That means this much pressure is also acted on us. So this huge pressure which is acting on us, which is called as atmospheric pressure, but we do not feel it. What is the reason? The reason is the blood which is flowing through our body exerts a pressure which is normally called as the blood pressure. This blood pressure is exerted on the wall of the arteries. The value of this blood pressure is slightly more than the atmospheric pressure. As a result of which, it counteracts the atmospheric pressure and we do not feel the atmospheric pressure on the surface of the earth. Similarly, if we go to a place where the atmospheric pressure decreases, for example, when you climb up a mountain, so at the top of the mountain, what will happen? Naturally, air pressure decreases with increase in height. So when you raise yourself to a certain altitude or height, atmospheric pressure decreases abruptly, so that the blood pressure now becomes too much increased. As a result, you may suffer from bleeding nose. Why? Because the blood pressure becomes so high and atmospheric pressure becomes so low that fine branches of arteries inside the nose, it may get burst due to the excess blood pressure, and you will suffer from bleeding nose. Now, atmospheric pressure is measured by an instrument which is called as barometer. Under the normal conditions of temperature and pressure, the normal barometric height is 760 millimeter of mercury column. Or you can say 76 centimeter of mercury. Now, air pressure has also some practical applications in our day-to-day life. First example, when you suck cold drink from a bottle with the help of a straw, When you put your mouth in the straw and suck, what you actually suck? You suck air out of it. So as air is sucked out, air pressure inside the straw decreases. But the atmospheric pressure which is exerted on the surface of the cold drink forces the cold drink to rise up through the straw and it goes inside your mouth. So this is a practical application of atmospheric pressure. Secondly, when you use a dropper to fill ink in your pen, or you want to take out some liquid medicine from a medicine bottle with the help of a dropper, you press the tip of the dropper. When you are pressing, the air is forced out. Clear? Now as soon as it is dipped within the surface of the medicine or within the surface of ink, air pressure exceeds the pressure of air inside that dropper. As a result, the liquid is forced up through the dropper and the dropper gets filled with ink or with medicine. Third example. When you want to draw medicine in a syringe, how do you do? You must have seen that the needle is put through the cap of the medicine bottle. Then the plunger of the syringe is pushed so that to drive away all air. Now whenever the plunger is withdrawn within the syringe, as the plunger is withdrawn, you will find that medicine rushes inside the syringe. Why is it so? Because there is very less air, or the air pressure is very low inside the syringe. As a result, atmospheric pressure increases. Atmospheric pressure becomes more with respect to air pressure inside the syringe. As a result, the medicine is forced through the hole of the needle inside the syringe. Clear? One more very practical example. You must have heard of siphon. You must have also practiced. Whenever you want to transfer liquid which is at a higher level to a vessel which is at lower level, what do? You thrust in a pipe, either a rubber pipe or a metal pipe. One end of the metal pipe is dipped inside that liquid which is at a higher level, and the other end of the tube is put inside your mouth. You suck the air out of it, and after that you find automatically the liquid starts coming out through the pipe into the vessel which is at a lower level. So this is called as siphon. So these are some practical application which we use due to pressure in gases. So children, I think we have covered everything about pressure, pressure in solid, pressure in liquid, and pressure in gases. By the way, one more thing I would like to tell you. The pressure of blood is measured by an instrument which is called as sphygmomanometer. Instrument used to measure blood pressure. So I gave you the name of three instruments. One is manometer, which is used to measure pressure in liquid. Actually, it is a simple device of which comes under pressure gauge. Second, barometer, an instrument which is used to measure atmospheric pressure. And third, sphygmomanometer, an instrument which is used to measure blood pressure. So you must remember the name of these three instruments. And we have come to the end of this chapter. So we have completed the first chapter in physics, chapter number 11, that is force and pressure. I want that everybody should write down the questions and answers given at the back of the chapter. If you have the book, then fine. If you don't have the book, you can try it out from your friends who are having the book to get a snap through WhatsApp so that you can get the questions. Go through the short questions and long questions. Write them down in your physics copy. And in the book, you will do all the objective questions, that is fill in the blanks. If you have true false, then true false. If you have match the following, then match the following. These things they will do in the book. And question answers you will write in your copy. Clear? So next chapter which I will do is metals and non-metals. Till then, goodbye. Thank you.